ಹಲೋ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಇವತ್ತಿನ ಸೆಷನ್ ಹೋಗಿ ಮಾಡೋಣ ರಿಲೇಷನ್ ಫಂಕ್ಷನ್ಸ್ ಮೇಲೆ ಇಂಪಾರ್ಟೆಂಟ್ 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್, ಎಕ್ಸಾಮಿಗೆ 100% ಗ್ಯಾರಂಟಿ. ಇದ್ರವರೆಗೂ ಒಂದು ಕ್ವಶನ್ 3 ಮಾರ್ಕ್ಸ್ಗೆ ಕಂಪಲ್ಸರಿ ಇರುತ್ತೆ. ಓಕೆ, ವೆಲ್ಕಮ್ ಟು ಸುಬೇದಾರ್ ಸರ್ ಅಕಾಡೆಮಿ. ಇಲ್ಲಿವರೆಗೆ ಯಾರು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಅವ್ರು ಯಾರು ಹೊಸದಾಗಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಡ್ರಿ, ಹಿಂದಿನ ವಿಡಿಯೋಗಳನ್ನ ಚೆಕ್ ಮಾಡ್ರಿ, ಹಾಗೆ ಲೈಕ್ ಅನ್ನು ಕೊಡ್ರಿ. Okay, now let's start with the first question. Check whether the relation are defined in the set 1, 2, 3, 4, 5, 6. Here we have 6 elements in the given set. It is defined as, the relation is defined as an ordered pair A comma B such that B is equal to A plus 1 is the relation. Whether it is reflexive, symmetric and transitive. Now here we have to check whether the relation is reflexive, symmetric and transitive. So solution is here given. I will consider the given set is A. Okay, given set is A equal to 1, 2, 3, 4, 5, 6 and the given relation R is defined as an ordered pair A comma B such that B is equal to A plus 1. Okay, this is a given relation where A and B are belongs to the given set A only. Okay, now to check the reflexive, symmetric and transitive, we have to first construct the ordered pairs of the relation. Here A elements are the input elements, these are the input elements, and whatever will come output, that is the B elements. Okay, here B is equal to A plus 1. So here consider B is equal to A plus 1. Now put A is equal to 1. Put A is equal to 1 because here we have 1 to 6. When A is equal to 1, 1 plus 1 is 2. When A is equal to 2, B is equal to 3. When A is equal to 3, B is equal to 4 because 3 plus 1 is 4. A is equal to 4, B is equal to 5. When A is equal to 5, B is equal to 6. When A is equal to 6, when A is equal to 6, because in the set A is 6 is also there, right? So B is equal to 7, but 7 is does not belongs to this set, right? So this is not belongs to the given set. Then what are the ordered pairs of the relation R? So here R is equal to, when A is equal to 1, B is equal to 2. This is our first order. Similarly, second one 2, 3, 3, 4, 4, 5 and 5, 6. These are the ordered pairs of the relation. Now we have to check whether this relation is reflexive, symmetric and transitive. So what is the property of reflexive here? Definition of reflexive. Reflexive definition is when A, A is belongs to R. If A, A is belongs to R for all the elements of the given set. For all the elements of the given set. But here 1, 1 does not belongs to R. First one the element illandalu it is not a one the ordered pair illantandru it is not a reflexive. 1, 1 ಬೇಕು ನನಗೆ 2, 2, 3, 3 ಎಲ್ಲಾ elements ಬೇಕು, even though 6, 6. But here we don't have 1, 1 in the given relation. So therefore R is not reflexive, right? So similarly symmetric definition, you know, if A, P is belongs to R, then B, A is also belongs to R. So therefore here I will consider any one pair here, any one pair. So 5, 6. You can take 1, 2 also, 2, 3 also, your choice. Okay, 5, 6 is belongs to R. Now we have to check whether 6, 5 is there in the given set. No, it is does not belongs to R. It is not there in the given relation. So therefore R is not symmetric. So therefore R is not symmetric. R is not a symmetric. Similarly for transitive also, we have to consider 2 pairs, right? So first consider, I will consider 1 comma 2 is belongs to R. 1 comma 2 is belongs to A comma B is belongs to R. Second pair we have to choose which starts from the element 2. In this ordered pair, which starts from the element 2. Now here we have only one pair, that is 2 comma 3. 2 comma 3 is belongs to R. Now we have to check whether A comma C is exist or not. That is in place of A we have 1 and in place of C we have 3. This is does not belongs to R. This is a does not belongs to R. So therefore R is not transitive. So therefore R is not transitive. So conclusion. So therefore given relation R is neither reflexive nor symmetric and nor transitive. This is the conclusion. Okay, write it down. Now take the second question. Second question is determine whether the relation R on a set A is equal to 1, 2, 3, 4, 5, 6 is defined as R is equal to an ordered pair x comma y such that y is divisible by x is reflexive, symmetric and transitive. Again here also we have to check the whether the given relation is reflexive, symmetric or transitive. So solution of this question. Here given is A is equal to 1, 2, 3, 4, 5, 6 and R is defined as an ordered pair x comma y such that y is divisible by x, right? So we have to check whether reflexive, symmetric or transitive, right? It is an in-general question. So reflexive. If x comma x is belongs to R, for all x is belongs to A set, right? It is a definition of reflexive. And also we know that every number is divisible by itself only. For example, here I will take one example. Example 2 is divisible by 2 only, right? 2 is divisible by 2 only. So that is R is reflexive because 2 is divisible by 2, right? Every number is divisible by itself only. So therefore it is a reflexive. So therefore R is reflexive. What about symmetric? Symmetric. If x comma y is belongs to R, that is here it is defined as y is divisible by x, right? So y is divisible by x. So it is a given definition, right? Here given relation. Now I will consider one example. Example 1 comma 2 is belongs to R, right or not? Because here 2 is divisible by, in place of y we have 2, in place of x we have 1. So that is 2 is divisible by two is divisible by 1. What about reverse case? Whether 1 is divisible by 2? No, because 1 is not divisible by 2. But 1 is not divisible by 2. That is 2 comma 1 does not belongs to R. If 1 comma 2 is belongs to R, but 2 comma 1 does not belongs to R, it means R is not symmetric, right? Similarly for transitive also, we will check transitive. If x comma y belongs to R, it means x is y is divisible by x. It is relation. And also y comma x, y comma z is belongs to R. For transitivity property, we need two order pairs. So y comma z is belongs to R. It means z is divisible by y. Z is divisible by sorry, y. So we'll consider one example here. Example, I will consider 1 comma 3 is belongs to R. That is here 3 is divisible by 1, of course. Second pair, I will choose 6 comma 3. Sorry, 3 comma 6. 3 comma 6. It means I will consider this one as belongs to R. It means 6 is divisible by 3, right? Then what about 1 comma 6? 1 comma 6. This answer should be, we have to get, right? 1 comma 3 is belongs to R. It means 3 is divisible by 1. Similarly, 3 comma 6 is also belongs to R. And also we know that 6 is divisible by 3, of course. Similarly, what about here? Whether now 6 is divisible by 1. 6 is divisible by 1. 1 comma 3 is belongs to R. Second pair 3 comma 6 is belongs to R. By transitive property, we have to get 1 comma 6, right? Also we know that in place of x we have 1, in place of y we have 6 here now, right? So therefore 6 is divisible by 1. Yes, it is true. So therefore R is 6, 1 comma 6 is belongs to R. So therefore R is transitive. Here the given relation R is reflexive, symmetric and also transitive. Right on. Third question. Show that the relation R in the set of Z of an integers given by R is equal to an ordered pair A comma P such that 2 divides A minus B. The difference between two number is always divides 2. 2 divides A minus B. Here the question is show that it is an equivalence relation. Show that it is an equivalence relation. It is easiest question because previous two examples are check. We have to verify whether the given relation is reflexive, symmetric or transitive. There should be, it may be reflexive or symmetric or transitive. But here they have only said that show that. It means reflexive is also satisfied, symmetric is also satisfied, transitivity property is also satisfied. Then only when these three relations are satisfied, then only the relation is said to be equivalence relation. So 3 marks easiest question, right? Here solution given A is equal to and R is equal to an ordered pair A comma B such that 2 divides A minus B, where A and B are belongs to the given set is integer, right? So first one reflexive property A comma A is belongs to R, right? If A comma A is belongs to R, A comma A is belongs to R, it means 2 divides A minus A. What is A minus A? 0, right? 2 divides 0. Yes, it is true. So therefore R is reflexive. R is a reflexive. Symmetric. ಇಲ್ಲಿ ಜನರಲ್ ಲೆಕ್ಕ ಇದಾರ, ಕ್ವಶನ್ ಒಳಗೆ ಯಾವ್ದು ಇಂಟೀಜರ್ಸ್ ಅಷ್ಟ ಅಂತ ಹೇಳಿದಾರ, ಸೆಟ್ ಆಫ್ ಆಲ್ ಇಂಟೀಜರ್ಸ್ ಅಂತ ಹೇಳಿದಾರ. ಸೊ ಯಾವ್ದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡಕ್ ಹೋಗ್ಬೇಡ್ರಿ, ನಿಮ್ಗೆ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತಾ, ಪರ್ಫೆಕ್ಟ್ ಇದ್ರಷ್ಟ ಕೊಡ್ರಿ. ಇಲ್ಲ ಅಂತಂದ್ರೆ ಜನರಲ್ ಆಗಿ ಬರೀರಿ, ಯು ವಿಲ್ ಗೆಟ್ ಆಲ್ 3 marks, complete 3 marks. ಓಕೆ, ಸೊ symmetric. If a comma b is belongs to R, that is defined as a 2 divides a minus b, because a minus b is an integer, right? Integer minus integer, again we are going to get a integer only, so therefore 2 divides a minus b. What about 2 divides b minus a? Yes, it is also true only. So whether it is minus 2 come or plus 2 come, okay, 2 divides 2 only. 2 divides minus 2 is also, because here we have set of all integers, there is no defined as positive integer or negative integer. They have said that all integers, so including positive, including negative. So therefore 2 divides b minus a also. So this implies b comma a is belongs to R. If a comma b is belongs to R, then b comma a is also belongs to R. So therefore R is symmetric, right? What about transitivity? Sorry. So what is transitivity property? If a comma b is belongs to R and b comma c is also belongs to R, next we have to show that a comma c is belongs to R. What is a minus b? Here a comma b is defined as 2 divides a minus b, and b comma c is defined as 2 divides b minus c, right? This implies whole bracket aayada. So this implies 2 divides I will add these two, a minus b, b minus c. So that is a minus b plus b minus c. So a plus b minus b get cancels. That is 2 divides a minus c. Yes, 2 divides a minus c, because a minus b is also an integer. This is also an integer. Adding these two, again we are going to get integers only. So therefore a minus c. So this implies a comma c is belongs to R. If a comma b is belongs to R, b comma c is belongs to R, then a comma c is belongs to R. Then we say that R is transitive. Now in this problem, R is reflexive, R is symmetric, and R is transitive, right? So therefore, since R is reflexive, symmetric, and transitive, this implies we say that R is an equivalence relation, right? Right? Hence it is proved. So next question, show that R in the set A is equal to 1, 2, 3, 4, 5 is given by R is defined as an ordered pair A comma B such that modulus of A minus B is an even number. We have to show that R is an equivalence relation, right? Here given is R is defined as an ordered pair A comma B such that modulus of A minus B is an even. It is given relation, right? Now so the given set is A is equal to 1, 2, 3, 4 and 5. A prove ಮಾಡಬೇಕು equivalence relation. For that we need to show that R is a reflexive, right? R is reflexive means an ordered pair A comma B, A is belongs to R. An ordered comma A is belongs to R. Whether, wait, sorry, A comma A is belongs to R, it is defined as modulus of A minus B is an even, right? That is modulus of A minus A is equal to 0. 0 is an even number, right? Very true. So therefore is an even. So therefore R is reflexive. What about symmetric? Symmetric. If A comma B is belongs to R, that is modulus of A minus B is an even, right? It is an even. What about modulus of minus of B minus A? We can write this one as minus of B minus A. After removing bracket, see here, minus of B minus A, bracket remove madri, we get minus into B is minus B, minus into minus plus A, or else A minus B, right? A minus B can also be written as minus of B minus A. So minus of B minus A is also an even, right? So that is the modulus of B minus A is also an even number. Then this can also be written as B comma A is belongs to R. Symmetric condition ಏನಂತತಿ? If A comma B is belongs to R, then B comma A is also belongs to R. Then we say that R is symmetric, right? So similarly, transitive and prove ಮಾಡಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? If A comma B is belongs to R, that is defined as a modulus of A minus B is an even, and we have to consider second pair also, that is B comma C is belongs to R, that is modulus of B minus C is even, right? Adding these two we get that is A minus B plus B minus C is equal to modulus of A minus C. Plus B minus B cancel aita. So A minus C is again even number. Even, because even plus even, again we are going to get even only. 2 plus 2, 2 is also even. This 2 is also even. So 2 plus 2 is 4, right? 4 is also even number. You can consider another number, 2 plus 8, because 2 is also even number, 8 is also even number. Adding these two we get again 6, it is also an even number, right? So therefore even plus even is again even only. So therefore here adding these two, A minus C is even, right? Then A minus C can also be written as A comma C is belongs to R. If A comma B is belongs to R, B comma C is belongs to R, then A comma C is also belongs to R. Then we say that R is transitive. So therefore R is an equivalence relation. Note it down. Next question. Prove that the relation R in the set of integers Z, positive integer, negative integer also, okay, is defined by R is an ordered pair. It is defined as an ordered pair x comma y such that x minus y is an integer. ಯಾವುದಾದರೂ ಎರಡು ನಂಬರ್ ತಗೊಳ್ರಿ, ಅದನ್ನು subtract ಮಾಡ್ರಿ, we get again integer also. Right? So solution. Here we have to show that this is an equivalence relation, right? So here given R is an ordered pair x comma y such that x minus y is an integer. Is an integer. So to prove equivalence, we need to show that R is reflexive, right? We know that x minus x is equal to 0. X minus x is equal to 0. So 0 is an integer. Is an integer. Therefore, we say that x comma x is belongs to R. This implies we say that R is reflexive. Similarly, symmetric. If x comma y is belongs to R, it is defined as x minus y is an integer, right? It is given. What about y minus x? What about y minus x? It is also an integer. Is also an integer. So then, if it is integer, then this can also be written as y comma x is belongs to R, right? Then we say that R is reflexive, symmetric. R is symmetric. What about third one, transitive? If x comma y is belongs to R, that is defined as x minus y is an integer, right? What about y comma z is belongs to R? I will take second order pair y comma z, because we have to take it start from y only, right? So y comma z is belongs to R. That is defined as y minus z is an integer, right? So what about adding these two? We get x minus y plus y minus z is also an integer. Is also an integer, because integer plus integer is again integer. So what about y plus minus plus get cancelled. So we remains with here x minus z is also an integer. Here x minus y can also be written as x comma y. Then x minus z can also be written as x comma z is belongs to R. So therefore this implies we say that R is transitive. So here we have R is reflexive, symmetric and transitive. Whenever R is satisfy all these relations, we say that R is an equivalence relation. ಹೌದಾ? ಯಾವಾಗ R reflexive, symmetric, transitive property satisfy ಆಗುತ್ತಲ್ಲ, ಅದಕ್ಕೆ ಏನು ಹೇಳ್ತೇವೆ ನಾವು? R is a equivalence relation. Very important. This example is very important. Mark it down. Next question. Show that the relation R in the set A is defined as x such that x is belongs to integers 0 is less than or equal to x, x is less than or equal to 12, 0 to 12, all the integers. Okay, defined by R is equal to an ordered pair x comma y such that a modulus of x minus y is a multiple of 4. Now we have to show that this relation is an equivalence relation. Okay, here given set is given A is equal to x such that x is belongs to integers and it is defined as 0 is less than equal to x, x is less than equal to 12. What about R? R is defined as an ordered pair x comma y such that modulus of x minus y is a multiple of 4, right? So to show that equivalence relation, we need to prove R is reflexive. We know that x minus x, modulus of x minus x is equal to 0, and 0 is a multiple of 4. 0 is a multiple of 4. If it is multiple of 4, then we say that x comma x is belongs to R. That is R is reflexive, right? What about symmetric? If I will consider x comma y is belongs to R, is already relation ಹೋಗೈತೆ ಅಂತ ಹೇಳ್ತದೆ. That is a modulus of x minus y is a multiple of 4. It is given, right? What about this can also be written as a minus of y minus x is multiple of 4. Okay. What about this one? Minus under the modulus. This is equal to y minus x also. Is also multiple of 4. So here if x comma y is belongs to R, then modulus of x minus y is a multiple of 4. If y minus x is a multiple of 4, this can also be written as y comma x is belongs to R. Then we say that R is symmetric. R is symmetric. What about transitive? Transitive. If x comma y is belongs to R, we need here two order pairs, right? First one I am considering x comma y is belongs to R. That is defined as modulus of x minus y is a multiple of 4. Second pair I will choose y comma z is belongs to R. That is modulus of y minus z is a multiple of 4. This implies I will add those two. Modulus of even ಮಾಡ್ತೀನಿ x minus y plus y minus z ಬರಿಬೋದಾ? Plus y minus y cancel ಆಗುತ್ತೆ. We remains with x minus z is a multiple of 4. So that is a modulus of x minus z is also a multiple of 4. Then we say that x comma z is belongs to R. Then we say that R is transitive. Whenever the relation R is reflexive, symmetric and transitive, then we say that R is an equivalence relation. Write it down. Very, very important. 3 marks. So next question, show that the relation R1 in the set R. Here R1 is the relation, but this R is a set of real numbers. Set of real numbers. Okay. So ಇಲ್ಲಿ R ಮತ್ತು R ಎರಡು ಕನ್ಫ್ಯೂಷನ್ ಆಗಬಾರ್ದು ಅನ್ನೋದಕ್ಕೆ ಒಂದು ರಿಲೇಷನ್ R1 ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ರಿಲೇಷನ್ R1 ಅಂತ ಡಿಫೈನ್ ಮಾಡಿದ್ದೀನಿ. ರಿಯಲ್ ನಂಬರ್ ನ R ಅಂತ ತಗೊಂಡಿದ್ದೇನೆ. Okay, is defined as R1 is equal to an ordered pair A comma B such that A is less than equal to B is reflexive and transitive but not symmetric. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ ವಿಡಿಯೋ ಸ್ಟಾರ್ಟಿಂಗ್ ಫಸ್ಟ್ 2 ಎಕ್ಸಾಂಪಲ್ ಏನ್ ಮಾಡಿದ್ವಿ ಚೆಕಿಂಗ್ ದ ರಿಲೇಷನ್ ವೆದರ್ ದ ಗಿವನ್ ರಿಲೇಷನ್ ಇಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಸಿಮೆಟ್ರಿಕ್ ಅಂಡ್ ಟ್ರಾನ್ಸಿಟಿವ್ ಇವನ್ ಚೆಕ್ ಮಾಡಿದ್ವಿ ಹೌದಾ. ನೆಕ್ಸ್ಟ್ 4 ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನ್ ಮಾಡಿದ್ವಿ ಇಕ್ವಿವ್ಯಾಲೆನ್ಸ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ. ಇಕ್ವಿವ್ಯಾಲೆನ್ಸ್ ಅನ್ನೋದಕ್ಕೆ ಶೋ ದಟ್ ಅಂತ ಹೇಳಿದ್ರು ಹೌದಾ. ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ ರಿಫ್ಲೆಕ್ಸಿವ್ ಸಿಮೆಟ್ರಿಕ್ ಟ್ರಾನ್ಸಿಟಿವ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತಾ. ಸೊ ದೇರ್ ಫೋರ್ ದ ಗಿವನ್ ರಿಲೇಷನ್ ಇಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಇಕ್ವಿವ್ಯಾಲೆನ್ಸ್ ರಿಲೇಷನ್ ಅಂತ ಹೇಳಿ. ಬಟ್ ಇಲ್ಲಿ ಏನ್ ಹೇಳಿದಾರ ಈಗ ಶೋ ದಟ್ ಅಂತ ಹೇಳಿದಾರ. ಬಟ್ ಏನ್ ಪ್ರೂವ್ ಮಾಡಕ್ ಹೇಳ್ಯಾರ ಅವರು ದಿಸ್ ರಿಲೇಷನ್ ಇಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂಡ್ ಟ್ರಾನ್ಸಿಟಿವ್. but it is not symmetric. Okay. Important 3 marks. Here given is given R1, relation R1 is defined as an ordered pair A comma B such that A is less than or equal to B. Right? ಏನ್ ಪ್ರೂವ್ ಮಾಡ್ಯಾರ ರಿಫ್ಲೆಕ್ಸಿವ್ ಮತ್ತು ಟ್ರಾನ್ಸಿಟಿವ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ರಿ ಇದು ನಾಟ್ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡ್ಯಾರ. ಸೊ ರಿಫ್ಲೆಕ್ಸಿವ್ ಏನ್ ಡಿಫೈನ್ ಮಾಡ್ತತಿ ಎ ಮೈನಸ್ ಎ is less than or equal to a relation. So A is less than or equal to A. Of course, here we have A is equal to A, right? A is equal to A. This implies an ordered pair A comma A is belongs to R. So this implies clearly R is reflexive. ಹೌದಾ? ಯಾವುದಾದ್ರೂ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ರಿ 1 is less than or equal to 1. Yes, it is true because here in this case we have 1 equal to 1. So same way here in generally we write this one as A comma A is belongs to R and R is reflexive. What about R is symmetric? ಅವರ ಹೇಳ್ಯಾರ ಇಲ್ಲಿ ನಾಟ್ ಸಿಮೆಟ್ರಿಕ್ ಪ್ರೂವ್ ಮಾಡ್ರಿ ಅಂತ ಯಾರ ಚೆಕ್ ಮಾಡತ್ತಲ್ಲ ಪ್ರೂವ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳಿದಾರ ಅವ್ರು. ಹೌದಾ? ಇಫ್ A comma B is belongs to R, it is defined as A is less than or equal to B. Right? I will consider one small example. 1 comma 2 is belongs to R. Of course, 1 is less than or equal to 2. How the 1 is less than 2? It is true, right? That is what about reverse case? What about reverse case? Whether 2 comma 2 is less than or equal to 1? No, because 2 is greater than 1, right? Which is not possible. So therefore, 2 comma 1 does not belongs to R. That is if A comma B is belongs to R, but B comma A does not belongs to R, then we say that R is not symmetric. Third one ಏನು ಪ್ರೂವ್ ಮಾಡ್ಬೇಕು ಈಗ ಟ್ರಾನ್ಸಿಟಿವ್ ಏನ್ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಟ್ರಾನ್ಸಿಟಿವ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದಾರೆ ನಾವು. ಹೌದಾ? ಇಫ್ A comma B is belongs to R, that is A is less than or equal to B. What about B comma C is belongs to R, that is B is less than or equal to C. Obviously A is less than or equal to C only. A is less than or equal to C. Then we write this one as A comma C is belongs to R. ಯಾಕೆ obvious ತಗೊಂಡ್ವಿ? If at all, for example, 1 comma 2 is belongs to R, that is 1 is less than or equal to 2. 1 is less than 2. What about 2 comma 3 is belongs to R? 2 is less than or equal to 3. Yes, 2 is less than 3. In place of A we have 1, in place of C we have 3. Then what about 1 is less than or equal to 3? It is also true only, no? So therefore 1 comma 3 is belongs to R. ಬರಿಬೋದಾ? ಸೊ ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ದಿದೆ. ಹೌದಾ? ಸೊ ಏನಾಯ್ತು ಈಗ R is symmetric, R is reflexive and transitive, but not symmetric. R is reflexive and therefore R is transitive. Hence proved. Alright, next question. So that the relation R in the set A of all triangles. Here A is a set of all triangles as defined as R is equal to an ordered pair T1 comma T2. T1 is one triangle, T2 is another triangle, but both are similar. It is defined as a T1 comma T2 such that T1 is similar to T2. Here we have to show that R is an equivalence relation. But given a solution, given R is an ordered pair T1 comma T2 such that T1 is similar to T2. So to show that R is equivalence relation, we have to show that R is a reflexive, right? So given is here, we know that T1 is similar to T1. T1 is similar to T1 only. So therefore T1 is similar to T1 can also be written as a T1 comma T1 is belongs to R. Then we say that R is reflexive. Similarly symmetric. If T1 comma T2 is belongs to R, it is defined as a T1 is similar to T2, right? T1 is similar to T2 ಅಂತ ಹೇಳ್ರಿ, or else T2 is similar to T1 ಅಂತ ಹೇಳ್ಬೋದಾ? T2 is similar to T1 ಅಂತ ಹೇಳ್ಬೋದಾ? Whenever we are writing T1 comma T2 as T1 is similar to T2, then T2 is similar to T1 can also be written as T2 comma T1 is belongs to R. Then we say that R is symmetric. Next, transitive. If T1 comma T2 is belongs to R, that is T1 is similar to T2. Second pair T2 comma T3 is belongs to R. Then we say that T2 is similar to T3. T1 is similar to T2 ಅಂತ ಹೇಳ್ತಾರೆ. T2 is similar to T3 ಅಂತ ಹೇಳ್ತಾರೆ. For example, I will consider this one as T1, T2, T3 is equal to either. T1 is equal to T2, T2 is equal to T3. Then what about T1 equal to T3? Yes, it is equal because all are equal only, similar. So T1 is similar to T3. Then we say that T1 comma T3 is belongs to R. That is R is transitive. Whenever R is reflexive, symmetric and transitive, then we say that R is an equivalence relation. So hence proved. So the writer very important. So next question is same question, but in the previous example T1 is similar to T2, but here the word is changed. The T1 is congruent to T2. Again we have to show that it is an equivalence relation. So given R is defined as T1 comma T2, that is T1 is congruent to T2. So we have to show that reflexive R is reflexive. So consider we know that T1 is congruent to T1 itself only, right? So therefore T1 comma T1 is belongs to R. Then we say that R is reflexive. Similarly, symmetric. If T1 comma T2 is belongs to R, T1 comma T2 is defined as T1 is congruent to T2, right? Or else you can say this one as T2 is also congruent to T1. So T2 is also congruent to T1. This can also be written as T2 comma T1 is belongs to R. Then we say that R is symmetric. Transitivity property proof. If T1 comma T2 is belongs to R, it is defined as T1 is symmetric. T1 is congruent to T2. T2 comma T3 is belongs to R. That is T2 is congruent to T3. What about T1 and T3? Both are also congruent. So T1 is congruent to T3. So therefore T1 comma T3 is belongs to R. Then we say that R is transitive. If R is symmetric, reflexive and transitive, then we say that R is an equivalence relation, right? Note it down.